Hello, welcome to today's video. Today we are going to discuss a linear versus polynomial versus rational equations and inequalities. We will see what's the difference between these three type of equations and inequalities, and we will analyze the graph of the equation. Okay, let's start the video. Okay, the first we see a linear equation. General form of a linear equation is f of x is equal to x plus b. So here x has only the power 1. So this is called as a linear equation. So here is an example of a linear equation 2x minus 4. From this example, we draw a graph. What we can identify, what we can observe from this graph. Look at this graph. There's a straight line. So this is the x value. So minus x to positive x. These are the x value. Okay. So these are the y values. What is mean by that? We can write either in this way or while we graphing for easy understanding we can write also like this: y is equal to 2 2x minus 4. Y is equal to 2x minus 4. That means x is the input, x is the x values we can substitute in this equation, and y is the result, the entire equation. After computing with the x value, y is the final value we are getting. So those values we are plotting in this graph. Okay, so all the points corresponding to each x values, all the dots, when we combine all the dots together, we got a straight line. So first, what we can understand from this graph is the behavior of a linear equation in the graph. It's a straight line. It's a straight line behavior. So we can only find a straight line in the graph. It crosses the x-axis. What point it crosses the x-axis? See, this is the x-axis. This is the x-axis. So x is equal to 2. That point, the graph crosses the x-axis. So it crosses x-axis at x is equal to 2. So this 2, the point 2 is very, very important. We call this as a root, or we call it as a critical point or an important crucial point where the entire equation is 0. So when x is equal to 2, what is the y value? The y value is 0. This is the y value. Okay, when x is equal to 2, y is equal to 0. So this is the crucial point. Then below this line, this is a negative y. Y is negative here. Okay, and above this 2, the y value, there is the y values, the entire function is a positive. So these are the two region. From this graph also we can understand that there's an interval. See, minus infinity comma 2. In this interval, the y values are negative. This is a negative one. Right? So the result is negative in this interval. And after this 2, I mean 2 comma positive infinity, the y values are positive. So this is a positive, and this side is a negative. So the below from this point, this is the negative side. Okay, and going upward is a positive side. So from this graph also we can identify this sign changing process. Then what else we can understand from this graph? The line divides the plane into two regions. The same. See that when we assume that this is a paper, it's a graph paper. When we draw a straight line like this also means the line cuts the paper into two. The left side, the region on the left side of this graph, the left side of the graph is region 1, and the region on the right side of this red straight line we call as region number 2. So these are the two region, one region on the left side and the one region on the right side. This also we can identify from this linear equation graph. A straight line, it cuts the plane into two region. Also there is x is equal to 2 where the graph crosses the x-axis, and the sign also changes from negative to positive. Without drawing a graph, a detailed graph of this linear equation, without drawing this graph, we can also find all these properties using a number line, a simple number line, and some algebraic techniques. So for our easy problem solving, we have another method also. So first, what we do is we need to find a crucial point, the critical point. That means the x value where the entire function, the entire expression is 0. So that point we need to identify. Then only we can mark it in a number line and find the interval and check which interval equation values are positive and negative. Okay, first we need to find the x values without the graph. So with using an algebraic simplification technique. So first assume that this entire equation is equal to 0. So 2x minus 4 is equal to 0. That means we need to find which value of this x makes this equation 0. So using some algebraic techniques, we can find it. So 2x is equal to 4. That means 4 coming to the right side. So then x is equal to 4 divided by 2. X is equal to, so we found the value of x where the entire equation is 0. So this is a crucial point, I mean critical point or the root of this equation. So just mark this value in this number line. This is the crucial point. Okay. But what else we can identify? We need to find the intervals. So these are the intervals which makes the two region. This entire, I already explained this linear equation graph cuts the plane into two. So the region before the 2 and the region after the 2. So here these are the two region. So minus infinity comma 2. Okay. Other region is 2 comma positive infinity. Before the 2 are, so the y values are negative. So here the entire expression is negative, and this region the entire expression is positive. How we will check this? It's very easy. Just the values before this 2 substitute in this equation, and we can see that is negative or positive. For example, we are substituting this 1 in this equation. So 2 times 1 minus 4 is equal to, what's the value? 2 times 1 is 2. 2 minus 4, of course 2 minus 2 minus 4 is minus 2. So the answer is negative. So we can say that the values x values before the 2, the expression giving the negative answers. What about the right side of this 2? So just assume 3. Just take this 3 and substitute back to the equation. So 2 times 3 minus 4 is equal to, so 2 times 3 is 6 minus 4 is equal to 2. Positive answer is positive. So that means the right side is positive. So this is how we find the critical point intervals. What will be the behavior of this indirect expression? That means is the negative, is the expression is giving a negative value or expression is giving the positive value. From this crucial point to the entire expression changing its sign from negative to positive, from negative to positive. So this is the 2 is the crucial point. So now we are going to solve a linear inequality equation. So same linear equation, we make a linear inequality expression here. Here what is meant by this? 2x minus 4 greater than 0. That means we need to find all the x values which makes the entire expression greater than 0. So here we already found that, which is the point 2, x is equal to 2. The left portion of the 2 is negative and the right portion of the 2 is positive. If we need the interval, we need the x values, the x values which makes the expression positive. That's very easy from this graph, and it's very easy from this number line also. Which are the radian? Yes, correct. This is the interval 2 comma 2 comma infinity. We can find using algebraic technique also the same thing. So 2x, so 2x greater than of 4, then the x greater than x greater than 2. So all the values above 2 we can consider, all the values above 2 which makes the entire equation positive, that means above 0. So we can write the interval as a 2 comma positive infinity. Okay, 2 comma positive infinity. This is the value. So here we can also find this using a simple algebra technique. Otherwise we can draw a graph, or otherwise you can draw a number line. Both techniques you can use. You can find the values of x which makes the inequality true. In a linear inequalities, we just check whether the line is above or below the x-axis. So here from the graph what we can see, the line which is below the x-axis and above the x-axis. So these are the two regions. So these two region we need to we need to consider, and the point which the line meets the x value or cross the x value. This is the only thing we need to care about in the linear equation or linear inequality. Next, we are going to see polynomial equation. How a polynomial equation look like and how a polynomial equation differ from a linear equation. See the behavior of the graph. Okay. See here, there's an example of a polynomial equation. F of x is equal to x square minus 5x plus 6. This is the corresponding graph of this polynomial equation. So x is the input, all the x values here we will substitute here, and y is the output. The output means the result. The draw is the red line. See, what is the first and foremost thing we notice from this graph? Yes, there is 2 points here in the x axis. There is 2 points, the 2 and 3. The point where this graph crosses the x-axis. 2 times this graph is crossing the x-axis. That points are x is equal to 2 and x is equal to 3. On that point, exactly the x is equal to 2 and x is equal to 3, that point the entire equation, the value is 0. X is equal to 2 and x is equal to 3. These two critical points. In a linear equation, we only find one critical point, one root. But here, when we move to the polynomial, here you can find two or more critical points according to the equation. F of x is equal to x cube plus 7x square plus x minus 9. Here it's a third degree polynomial. It is a third degree polynomial. So the highest power of x is 3. Here see how many times this graph crossed this x-axis. It's a parabolic shape. Yes, the quadratic is a parabolic shape, but when we move to the third degree polynomial, it's a parabolic shape, but two parabola joined together in the opposite direction. Okay, just come back to our original equation, the quadratic form. We will analyze some more things from here. What we can see is the graph behavior is a parabola shape. It's a parabola shape. The behavior of the graph is a parabola shape. The graph crosses x-axis at 2 and 3. As we already discussed, 2 and 3, the graph crosses the x-axis. Then it creates three regions. See, this is the important thing. Which are the three regions here? The three regions here, one is above 2. Above 2 means here. This is the one region. Below the axis between 2 and 3. Below the axis between 2 and 3. This is the another region. Then above axis after 3. Above the axis after 3. This is the another. So one region is here, and this is the second region, and this is the third region. Why? Because the graph, see the graph is coming. The graph is coming from the decreasing. When the x value is increasing, x values are increasing from the left side to here. The graph is decreasing at the point of 2 and crosses the point. From this point, then the graph is again going back to the positive direction. In this area, the equation giving the negative values, and after the 3, it's again giving the positive. Okay, so the intervals will, what are the intervals here? The first interval is from here to here. This is the first interval. Okay, second interval is this region. Second interval. Third interval is from here to infinity. This is the 3 interval. Let's write in the interval notation. These are the 3 intervals. So from the graph, we can identify that the first interval minus infinity to 2, the graph values are positive. Okay, positive is the graph values are positive. In the between 2 and 3, the graph goes down to the negative direction, negative side. So here it will be negative. In this interval, the equation gives a negative values. Then after the third interval, like 3 to infinity, again the graph is going back to the positive range. So it's flipping. Without drawing the graph, we can also analyze this characteristic using a number line and some algebraic techniques. We are going to factor this quadratic equation. How we will factor this? X square minus 5x plus 6. We need to get the value of positive 6 when the two the two numbers multiply. We need to get answer 6. When it's add, we need to get minus 5. So those are those numbers, and those numbers are very easy. This is minus 2 and minus 3, because minus 2 plus minus 3 minus 5. Minus 2 times minus 3 is 6. Okay, so the factors are x is equal to 2 and x is equal to 3. See how we find 2 and 3. So the critical points, we can find this critical point using the algebraic techniques also without drawing the graph. Okay. Then now what we need to do is, so let's make an interval notation. For example, it's an example only. Example, x square minus 5x plus 6. We need greater than 0. So we need to find all the values of x which makes the entire equation greater than 0. The greater than 0 means the value should be above the x-axis. Okay, now we got the two critical points here. So we will mark these two critical points in a number line. Okay, for example, here we start from here 0. So marking these two critical points here, 2 and 3. So one critical point is 2, the critical point is 3. By marking these two critical points, we divide the entire number line into three regions. One region is coming this interval minus 122. This is one region. I mean, one interval. The second interval is 2 comma 3, second interval. Third interval is 3 comma infinity. These are the three intervals. So we got the three intervals. So we need to check these three region. What the sign of this equation? So how you will find it? Substitute each value. Select one value from the interval and substitute into the equation. Then analyze the result. Maybe it's positive or negative. So the same thing will have a result when we doing that. This area will be this interval will be positive. That means this this area, this the middle portion, the 2 comma 2 will be the negative, and the third one 3 comma this interval will be positive. Okay, so how we will find this without drawing the graph? Mean just substitute each value from each interval back to the original equation and analyze the result. If the result is positive, then the entire sign will be positive. In the next interval, if they are substituting this, the result will be negative. Then this interval, the sign will be negative. Like that you need to find. So now our actual question is, which all the values of x which makes the inequalities greater than 0? That means we need to only select interval which is positive. That means the two intervals are here positive. This one and the first one and the third one. So this minus infinity comma 2, first interval, and the second one is 3 comma post infinity. These are the two set of x values which makes this entire equation, entire quadratic equation above 0. I mean greater than 0. That means we are considering only the values above x-axis. That means the positive values. The negative values we are skipping because our inequality says we need to select only greater than 0. Okay, so these two sets, so we already learned how to combine these two intervals together using a union function. Okay, so these are the solution of this inequality. So quick solving, we need to follow some algebraic techniques by factoring and finding the critical points, find the intervals and substitute the interval value back to the equation and find the change of sign. So we need to take the which are all the values we need according to the inequality equation and write the final solution. Polynomial graphs can cross the x-axis multiple times, so the sign can change several times also. This is the important characteristics of a polynomial equation or polynomial inequality. Next topic is a rational equation. See, what's a rational equation means? A rational equation means a polynomial in the numerator and denominator. And by definition, it's saying it's a fraction which contain a polynomial in the numerator and denominator. The polynomial can be in a first degree polynomial like a linear equation, or a second degree polynomial like quadratic, or third degree, fourth degree, any degree. The main thing is it should be a polynomial in the numerator as well as in the denominator. That is called a rational equation. Here you can see one example here. F of x is equal to x minus 1 by x minus 3, because it's a linear equation, the both numerator and denominator. Okay? It's the graph is look like the two separate graphs. One is going like this and moving back to the negative. Another one is going from the positive infinity of the y value to the 0 to the y value. So from the top to the bottom. This is the same graph, but little more zoom out. By seeing this graph, you can see that uh, there is some point here. The y value cross the x-axis. When the x value increases, what happening to the y values here. Y values also decreases towards the 0, and when at a point here it's moving to the negative, so that means it's a decreasing. What about after this point? What happened? Suddenly the suddenly when the x crosses this area, suddenly the graph jumped to the higher value, and also now also going down to the 0. So you can see that how the y values are changing according to the x values. Here we can see critical points. What are the critical points here? According to our previous observation, the, the point where y value crosses the x-axis, that is called a critical point. But the point where the x value which makes the numerator 0, 1. So if we substitute x is equal to 1 here, the numerator will be 0. So 0 divided by any value is equal to 0. So the 0 of numerator is graph which crosses x-axis. This is the point 1. This is the point where the graph crosses the x-axis. Which is that point 1? 1 means x. If we substitute this 1 in the x here, what happened? Numerator is 0, denominator is minus 2. So 0 minus any value is equal to 0. So this is the point where the graph, where the entire equation will be 0. Then there is one more point which is a new topic to you. See, 0 of denominator. See, what value make this equation denominator 0? If we substitute 3 into the x, what will happen? A denominator is 0. Any value divided by 0, what is meaning? 0 is not possible. We cannot divide any value with 0. If a solution makes denominator 0, reject it. We need to reject that solution. We cannot consider that solution. That kind of x value, that kind of solution we call as extraneous solution. X is equal to 3 is an extraneous solution. So we cannot consider this. The value which makes the denominator 0 we call as a vertical asymptote. Vertical asymptote means, which is the point x is equal to 3. Here, just analyze the point here. X is equal to 3 here. See, this is the point. This is the point where the function has no solution. Vertical asymptote means when x values are moving closer to this point 3, the y value will be maximum. I mean the infinity minus infinity, the maximum. Suddenly when the x values touch the 3, suddenly the minus infinity it jump to the positive infinity here. So the sign is flipping. Okay, the sign is flipping. Then again this graph will continue like this, going slowly down. Okay? This is called a vertical asymptote. From this, what you can understand is, when we deal with the rational equation, we need to make sure we should not consider the value which makes the denominator 0. Okay, that type of value we call as extraneous solution. Both can cause sign change. Even the vertical asymptotes and the critical point, both can cause sign change. I mean from one positive to negative here. Vertical asymptote is also, see, negative to positive here. Both can cause change in sign, but only the numerator, see, even the value which make the numerator 0, that point only allows a crossing of x-axis. Change in sign, this vertical asymptote is also change in sign, but there is no crossing here. X-axis crossing not possible here. But in the numerator, the value x value which makes the numerator 0, that value, that point only, the critical point only allows the crossing of x-axis. Okay, so let's see the behavior of the graph here. The graph crosses at x-axis. Okay, you already saw the graph crosses at x-axis here. The point 1, x is equal to 1, the graph crosses the x-axis. The vertical asymptote, x is equal to 3. In this x is equal to 3, here, this point, this is the vertical asymptote. The graph, when the value of the x moving closer to the 3, this y value will be go maximum negative infinity. Maximum to the infinity. Okay, when the x value almost touches the 3, there is no solution. Suddenly in this point there is no solution for this equation. Then after the 3, suddenly the y values jump to the maximum positive infinity. See, positive infinity here. From the positive infinity, again the graph will go down like this towards the 0. So this is the behavior of a rational equation. So then here we can see the intervals. What are the intervals here? Minus infinity to the critical point here, 1 interval. Okay, then 1 to this vertical asymptote is 1 comma vertical asymptote, this is 3, another interval. Then this vertical asymptote to plus positive infinity, that means 3 comma infinity. These are the 3 intervals. Then for example, when we are assuming that this f of x, I mean this x minus 1 by x minus 3, this is the rational equation for our example rational equation. Assume the inequality we are putting here greater than 0. I mean we need to consider only the values of x which makes the graph, which makes the equation positive. So the negative values we need to neglect, we need to avoid. Only we need to take the values of this function above 0, which are the intervals which gives the equation value positive. Yeah, this is the interval minus infinity to 1. From minus infinity to 1 is a positive sign, it's a positive y value, that means positive y value. Then 1 to 3, 1 to 3 is, yeah, critical point to vertical asymptote is negative, so it's negative sign here. Then what about 3 to infinity? I mean vertical asymptote to the positive infinity, positive value. So this also positive. So we need to consider only this one and this interval. So the x values are lies between minus infinity comma 1 union 3 comma positive infinity. These are the values we need to consider by solving this rational equation inequality. So let's see some definitions regarding this rational equation. See, a rational expression become undefined only when the denominator is 0. Denominator is 0 means vertical asymptote. If the numerator is 0, the function value becomes 0, which is perfectly valid. When the function value is 0, it's okay, we can include 0 also. If the inequality says greater than or equal to 0 means we need to include this 1 also. A function which makes the result is 0 means it's acceptable. But the vertical asymptote, that means the extraneous solution, there is no solution. If denominator is 0 means we cannot do anything, we need to stop right away, we cannot go any more further algebraic techniques, or we cannot apply any calculation furthermore. The rational functions are more complex because the graph can break and create vertical asymptotic. Dealing with the rational equation is a little more complex and complicated. So we need to understand the basic things when we encountering any rational equation.